Hey, kids. So, we're going to talk about some more things about the normal curve and when we can use it, and some more specialized problems. So, first of all, if we were given a mean, standard deviation, and a maximum value, would we be able to model something with a normal distribution? So, remember that if it's the perfect normal curve, we would expect the normal curve to be smooth and nice and cover, oh, that was not smooth and nice, um, about three standard deviations, right? So we have our mean, and then we divide this into thirds. And we do the same thing here. We have thirds. So we're like out at plus three standard deviations and out here at minus three standard deviations from our mean. And so that's if it's like platonically ideal, but it definitely keeps going, right? This is an asymptote, so this is just 99.7% of the data. We can model something with a normal distribution if it's at least two standard deviations. So our model, we want to be able to solve problems, so we're looking for something that's at least two. Because this maximum value is less than one standard deviation away. If I go 89 plus 8.4, I'm past 95. The maximum is less than one. We could say that this is skewed to the left and that this is not going to be symmetric and unimodal enough for us to use a normal model. It needs to be at least two standard deviations above and below the mean for us to be able to use a normal model. All right, so here's the big kicker of a problem. We have the Podunk SAT, right? So when you're taking the PSAT, if you're a junior or sophomore, think about the Podunk SAT. And we have scores that we have a couple cutoffs here. Now, notice that one thing that we really look for is that this is approximately normally distributed. If they really were looking at the data, probably put onto a normal distribution for scores, but here we go. And so when we're doing this, we are looking at a distribution that is approximately normal, but we don't know the mean or the standard deviation. That's what we're trying to find. So we don't know that. But I do know that the 90th percentile, if I cut off here, this is 0.9 of the curve, this is 0.1 of the curve. Okay, so 10% here, 90% here. This is the 90th percentile is at 674. And the 30th percentile, 0.3 here, is at 544. So we have these two cutoffs on the same curve because it's the same mean, same standard deviation. I didn't put 0.9 here because I didn't want it to be confused with this other cutoff. So 0.1, 0.9, all the way to the end. We have that, right? So what we're going to do is we're going to use two z-scores. I have the z-score for the lower value, and that's equal to 544 minus the mean divided by the standard deviation. And then I got to get my calculator to do inverse normal of 0.3 to the left. I'm looking up this area to find a z-score, because this is what this is, z-score, for the the 30th percentile, right? So 0.3 to the left with a mean of 0 and a standard deviation of 1. When I'm on the standard normal curve, I'm over on this curve. Oh, whoa. Right? Normal 0, 1. And I'm looking up that 0.3, and I'm going to get z-scores in the x-axis. So this is going to give me a z-score of negative 0.5244, and it keeps going. And I'm going to leave all those digits in my calculator. And then I'm going to come over here and I'm going to get the z-score for the higher value, and that is 674 minus the same mean divided by the same standard deviation, and I get inverse normal of 0.9 to the left or 0.1 to the right. Either way we go. And I'm putting in my calculator, and I got 1.2816. And really 155, blah, 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 blah. It really keeps going. I'm going to write rounded numbers, but I'm on a calculator. I'm leaving every digit in the calculator that I can use. So I'm going to write a system of equations. I have two variables and two unknowns. So two equations and two unknowns. So I'm going to go and multiply both sides by sigma. When I do that with this equation, I have 544 minus the mean equals negative 0.5244 sigma. And then I'm going to add the mean on both sides. So I have 544 equals mu minus 0.5244 sigma. Then I'm going to do the same thing with my higher equation. 674 minus the mean equals 1.2816 sigma. And then 674 equals mu plus 1 point, there should be a decimal there, 2816 sigma. Okay, now we're almost ready for elimination. I think most kids like to see positive numbers, so I'm going to take away this second one from the first one because 674 minus 544 will be positive. So I'm going to subtract this second equation. And by doing that, the means mu will cancel out. Right? So it's minus this, minus this, minus this. Well, when I minus a negative, it's actually plus. And I'm going back into my calculator. I'm getting all those digits minus all the digits that I had for the other z-score. And I have 130 equals 1.80595 or 806 sigma. Now I, again, have all those digits in my calculator, but I got that there. And then I'm going to do 130 divided by what my answer just was. And I have 71.984 equals sigma. There is my standard deviation. Okay. So then I go and write that down. 71.984. So now I'm going to go and I'm going to plug that back in right here. So I have 544 equals mu minus 0.5244 times 71.984. And again, there's a lot more digits here. There's a lot more digits here. I'm going to go get all of those. And I got, when I'm all done, mu equals, I multiplied this out and then I'm adding it to the other side because this is a negative. I got 581.749. Okay. So we got all that. And we're in business. That looks great. I got my mean. I got my standard deviation. Now I'm going to check it. I'm going to go back to my curve. And I'm going to say this is normal with 581.749 and 71.984. That's a mess. I'm sorry, kids. And I want to see if 544 or less would give me 30%. So on my calculator, I'm going to do normal CDF just to check my answer. So I go to distributions, normal CDF. My lower is negative 99999. Upper is 544. The mean is that mean that I just got, 581.749. My standard deviation is 71.984. And I hit paste and I got 0.299999. It's definitely going to round up 30%. We got it right. Good job. High five. That's a system of equations. Now, Mr. Yoon also did some work where he did substitution instead of elimination, and his handwriting is infinitely better. So here's the substitution steps. Same z-scores. Notice he rounded a little bit more than I did, so there may be some rounding error that's about to happen. he multiplied both sides by sigma and divided by the z-score. So we got sigma equals for both of these. And since two equations are equal to the same thing, we can set them equal to each other, then do cross products. Well, come on, cross products, distribute, get all the mu's together, and divide. And we get something in the neighborhood. Mine, a little bit more precise, less rounding. I got 581.749. 581.76 is close enough for what we're going to do. And we'd still get something that would round to 30% if we check that lower cutoff. Last time I got 71.98. Here's 72.06. Again, that's because our z-scores are rounded here, and it caused us to have some rounding error. So if you use all the digits in your calculator, you'll have a little bit more precise of an answer. All right, kids, that's solving a system of equations using the normal curve.